Yeah, nice to be here and nice to see so many of you here. I will talk about something rather new, actually. The concept of habitat functionality is maybe very old, but in the way it is analyzed nowadays, I think it will be a very promising tool for different kinds of impact assessments or assessment of current infrastructure to see what can be done with it to improve the functionality of the landscape, which was discussed earlier today. And this is a little bit of the sketch I will go through. Big deal with that, but to start with, I have been working for a couple of last years now with a project that was funded by the Swedish Research Council, which the main project there aimed to make GIS tools to make more effective integration of different parts of the environmental when doing assessments of transport infrastructure, integrating both social economy, ecological, and cultural historical aspects to see. Sometimes you gain something by doing that mitigation, but it could be a negative impact of that mitigation on other things. So that is very interesting framework to work with. But in this talk, I will focus on the ecological issues. Effect analysis of transport infrastructure, which I told you, the new concept here is to work with habitat network modeling very strictly using the pixel values, the raster-based approach. In many cases, in all the times, one have used the vector-based, where you really need to find what is patch and what is the path between them. And in this approach, you focus on every pixel in terms of quality and connectivity. And what you find, the benefits of that is you get something that are really responsive to the changes which become imposed by new transport infrastructure of different kinds, even if it don't hit any habitat or whatever. And also the mitigations work very well with this approach. And models to be effectively used when doing effect analysis must be responsive to these changes. And not only responsive to the habitat loss that are caused by the so really the barrier effects and how can that, and also the mortality. Sometimes the mortality is more important than the barrier effect per se. But of course, the mortality also falls a barrier effect in that. This approach is more applicable to more organism groups due to the one thing is that you don't need to really define what is the habitat and what is not habitat. You can think of the whole landscape with different quality of each point step, which make it more applicable for many species actually. And that is important because you have to deal with very much of the biodiversity. We talked with the goals that we have talked about earlier in this conference, or that we talked about. And a very good thing with this method is that you get an instrument to find where to do the restorations. You don't have to guess that. You can look at the whole landscape and use the results from these analyses. Get a map where you can really discuss where this is optimal. So I hope this is a rather new concept. Here's 3 publications that have come, which 2 of them are somewhat related, and one is by myself, a little bit old, but they didn't call it habitat functionality that time. And these papers are rather good. I think they explain the concept. The ecology paper is very good to describe the new concept, describe the difference to our similar things. The techniques are old, but nation as well. Right. And the research program that I have been working with for the last years, we have developed also tools that can do this kind of analysis certain way and do it very ethically for many species at the same time. And the input for this analysis is a land cover map, not maybe the original land cover map, but the land cover map that have been managed in a way that you have added things that are very important for the species that we want to model. It could be that you really need to add old trees or ponds that are smaller in scale than the actual resolution of the natural land cover or European land cover. But that can be done. So you have a raster file for the input, and you have an Excel file which have all the parameters for all the species. And then you run it as a plugin in QGIS, and you get several maps for each of the species that you model at the same time, which can be very useful in different ways. And we will focus on this one, habitat functionality, this talk, but that is a product of a map which shows quality in space for every pixel and the connectivity in that. So the functionality is like multiplying the probability of dispersing individual reaching each point with the quality. So you get some kind of realized quality or functionality. So it could be spots in the landscape which is very good in terms of how much resources there are for the species that you model, but are not reachable from, for example, reproduction areas or nesting places and so on. And then it's not functional. So it has to be both good quality and high connectivity to that place to be a highly functional place. Let's go through the different maps here in an example north of Gothenburg. Here we have the quality map, and the darker the bluish, the higher quality. And we have some reproduction places here also for amphibians, which is the case here. This is very much a map like you can get from this habitat suitability methods that are used by ecologists very many times. But in this case, the quality aspect is based on the biotope out there. And then combination with idea, expert-based idea of how relatively good is that habitat or that biotope for the species. And then we have the dispersal probability map, which in this case is modeled in a way that take into account all the pixels have a parameter that or the biotope at that pixel determines how permeable the environment is for the total species that you model, which make, for example, roads could be a great barrier in a way that affect this dispersal probability. And then when we multiply these two maps, each pixel, so you get the habitat functionality map, which have the same range of values as the quality map, but it's weighted with the connectivity at each pixel. And the red areas are the most functional, and those are also reproduction environments. And as they spread from these, every individual is born at those places, And they will also return for reproduction. They will have to move. They are restricted in the landscape. Connectivity is very much restricted by this, the distribution of ponds in this case for frogs. And you get higher functionality closer to ponds, but you also get impact of the roads and everything else that are in between if they are not, if they act like barriers. And based on such a map, you can identify quite easily by selecting a threshold areas which are at higher functionality than others. So like high functionality hotspots. In this case, I just selected 5 as the intermediate value of the functionality. And when you delimit it in that way, you cover 90% to 95% of the observations in the landscape as a whole, which is a way of not telling that to think of the patch approach, you can identify patches in this way that are functional, not delimited by an expert out in the nature just looking at the biotope itself. And what can we do then with the effect analysis? We can do a scenario analysis where we take away roads, add roads, and whatever. In this case, we add a road here. So this orange line is the treatment in this case. And what we see here is the dispersed probability. No big differences. This is before the road was built. This is after. And this is the difference between the two dispersed probability maps. And then you find this area is like an influence area. The road make this influence. And you can notice why is here something. Here is happened a lot of big decrease in dispersal probability on another road which was not that were existing before this road was built. And that was due to the traffic change. Traffic change will increase the road. And that is a good way of finding these effects. But what you can see on the hotspot areas, they don't change very much. So if you actually have focused just on the functionality here, it might be that you conclude that it's not that bad to build this anyhow, this in this case. In other cases, it would be that those become fragmented, those high functionality spots. And you can also work with mitigations. In this case, we compare building a pond, the other side of the road, with amphibian tunnel. And what you can see is that dispersal is much higher on the other side of the road with making new pond. And with the functionality, it becomes actually a hotspot on the other side. While just doing a passage for the amphibians will not decrease the functionality or increase the functionality very much. But actually the pond created a better situation than for building. And when thinking about restoration, such thing, this is really important thing. And I will end with this. This is a map showing where to put restorations. It's a map that you can produce by taking the quality map minus the functionality map. The general places where you can create high functionality by just adding one. In this case, we decided that one there, which is not maybe optimal, but it's maybe a place that we can control over because we own the land. I think that is really a method for working with restoration. Thank you very much.
Thank you very much. And I think we have time for one question.
Fantastic, super. I hope that, I mean, we can discuss the algorithm, the way you calculate stuff, but I think this idea, I hope is what it is. So, we are doing the same thing. So we're struggling with one thing, so exactly. And at the end, we use the same corridors. At the end, what we are struggling with is we haven't yet understood what is the minimum functional habitat to sustain a viable population. In the sense, we are finding functional habitat everywhere. But then people ask me, yeah, but can I have a moose population there? Can I have a rain population? So did you think of this?
Yeah, I'm working a lot with population dynamics. This is not the way you model population dynamics. This is the way you model the prerequisite, the things that are needed for it. So you can go further on to model the population based on this, and then you can find long-term different ways of solutioning it. And if you also want to add effects of mortality and such things, you can do that as well.
So thank you very much. And we move to the second presentation, which will be given by Peter Lanel. It's yours.
Okay. Yeah. Hello. We are currently working on the Plan to Connect project. This is an Interreg Alpine Space project, and it is about mainstreaming ecological connectivity in spatial planning instruments. So here I want to show you some first results of this project. We are trying to find out priority ecological connectivity areas for spatial planning interventions, and we try to elaborate the potential ecological network and to find out the most important human barriers in the alpine space. So first of all, we collected all the existing ecological connectivity concepts which are present in the alpine space. They are concepts which have a formal character because they are provided by administrative officers. You can download it, they are public. And they are very detailed, so they are actually used for local implementation. However, these concepts, you can see that the picture is not complete, so there are some missing concepts. So especially where we come from, South Tyrol, it has no provincial ecological connectivity concept. The core areas, linkages, and permeable areas, so the landscape elements are not harmonized. You can see that especially at the state boundaries, so country boundaries. And we cannot see priority linkages, which would be important for a macro-regional level. And therefore, we used these concepts for options to improve ecological networks, and we focused on two options: create new sites and enhance connection between the sites, because those are the two options which have a very strong spatial impact and spatial focus. We started not from scratch. We started from the EUBIOCOR 2030 project. So they elaborated a concept or like a analysis based on the continuum suitability index. This is based on 5 factors. So this is a landscape permeability model for a species on land. These 5 factors are land use, population, environmental protection, fragmentation, and topography. Those are transferred to a range from 0 to 10. So 0 means low permeability and 10 means high permeability. And those are categorized in 3 categories. So actually a continuum suitability index higher than 8 means it's a very good area for ecological connectivity. At the other side, we have ecological restoration areas. You can see them in red here in the map. They are the main human barriers. And in between, there are these so-called development areas. And this concept is based how these development areas should connect the ecological conservation areas. So this first category. And here it was developed with the circuit theory. You can see these big areas in orange. So, but now where is the priority if everything is a development area for ecological connectivity? That's why we try to have a closer look. And coming to the option of creating new sites, we found out that these SACA 1 areas where ecological permeability connectivity is working actually very good. Most of them are protected, but 8.1% are not protected. So the most of them are located in Switzerland. I don't know why, probably because Switzerland is not within the European Union and they are not forced to install Natura 2000 sites, but this is just an assumption. And then we focused on the section option to enhance connections between these SACA 1 areas. And here we did several steps. So first of all, we grouped these SACA 1 areas, those who are closer than 2.5 kilometers and bigger than 300 hectares, sorry. And you can see them here and calculated the least cost paths between this based on the continuum suitability index as a resistance. So you can see them here in violet. At the next step, because this is only a structural approach, we compared this with the national concepts that we collected. So here you can see here you can see the wildlife corridors of Austria in green color that are overlapped with the corridors that we calculated in violet color between Salzburg and Vienna. And we had to, so with this overlay, we found out that like 150 corridors were not overlaying with the national concepts. So we tried to eliminate them just to give them also like proving that they are really existing. So the result is 953 linkages, which is still quite a high number. And this would be the whole picture of an alpine ecological potential network. So here we can see the linkages at macroregional level. They are harmonized by one methodology, but obviously this is just an informal concept. And for an alpine-wide scale, it is very hard to go to have a very detailed level of analysis. So for local implementation, there are additional analysis needed for each of these corridors. But then we wanted also to find out which of these, of such many corridors have a high priority. We used like this scheme when we did it with 2 dimensions. So one is the urbanization threat, and the other one is a contribution to the network coherency. Here we used 3 indicators. So for example, type 1 corridors would have the highest priority. They are important corridors to keep the network together. And at the same time, they are at risk by urbanization because they are passing through a bottleneck caused by urbanization of 300 meters. So 300 meters in an alpine-wide level is not very much. That's why we assume that they are kind of threatened. And at the other side, type 4 corridors are the least important ones to protect it at the moment, let's say. And those are corridors supporting the overall network, and they are not threatened by urbanization. So type 2 and type 3 are somewhere in between. And to explain more, a little bit more in detail, the urbanization threat. So these are settlement, like say bottlenecks caused by settlement development. And 309 linkages have a bottleneck of 300 meters caused by urbanization. And especially in the outer alpine space, not so much in the inner alpine space. And this was quite surprising for me that the number is so high. Then the second dimension regarding the network coherency, we used, first of all, the minimum spanning tree. So this is the network of the shortest linkages and connect each core areas. And second, we also checked the centrality. So this defines the importance of a linkage for keeping the overall network together. And third, we used these so-called connectivity areas. You can see them here in dashed. So these are linkages coming out from an expert workshop in the AlpBioNet project. And those are the areas which are connecting the inner alpine space with the outer alpine space. And so this would be the overall picture. And here we can see obviously that type 1 and type 2 linkages are mainly in the outer alpine space, located mainly in the outer alpine space because they are threatened by urbanization. Yes, while type 4 linkages are more in the inner alpine space. At the end, we also did a closer look to the barriers, to the human barriers. We have 160 sections of sucker-free areas that are in average 1.5 kilometers long. And sucker-free areas are areas like in the picture here in the south of Bolzano, in the Adige Valley. They are full of intensive agriculture, settlement development, and transport infrastructure like railway or motorway areas, lines. Sorry. And we have also a closer look to the motorway intersections with these regional corridors, and identified 150 motorway sections on these motorway intersections, which are a real barrier. And at the other side, we identified also motorway intersections where there are green bridges located, and this was quite interesting to me because I identified 10 green bridges on a motorway intersection, and here actually the reality is confirming the model because before we didn't know that there is a green bridge already existed. 6 linkages have a real settlement barrier. I think those are the ones that are really hard to restore. And we also identified 3 solar panel fields because we think that the upcoming solar panel fields can be a new barrier or upcoming barriers and upcoming threats for ecological activity. And obviously the intensive agriculture is very present. And so more than 2,000 kilometers, these corridors are passing through intensive agriculture. So here it should be checked if they are really put to work or could be restored. So to give you some possible applications of the model, we can find indications for the creation of new sites. So those are the not protected sucker 1 areas. We can find indication of priorities. So spatial planning offices could use their instruments to focus on the protection of type 1 and type 2 linkages. And we can also find restoration priorities. So, for example, to focus on to dismantle motorway barriers or also other barriers on type 2 and type 3 linkages because they are important to keep the whole network together. And now we have also a more detailed picture of the corridor sections which are passing through such a intensive landscape, intensively used by humans. And last but not least, obviously, as I said at the beginning, such a model could also facilitate the harmonization process among the countries of the Alpine space. Just to show you a short, yes, I give you some hint about our case study. In South Tyrol, here in the red arrow shows a linkage with it, which is a priority 1. We have the green arrows, which are actually existing corridors that are important to keep the whole network, the whole Alpine network together. And violet arrows are linkages that are important to keep the whole network together but they are just potential corridors. So here you would need a big restoration process. So for further information, I provide some links and I'm available for questions. Thank you.
I'm interested to ask, what do you have some kind of studies or ideas of how to test whether these links are used by the Alpine organisms? Because it's
yes, for example, this, as I showed before, it is here in this point. In our case study in South Tyrol, we have lots of wildlife vehicle collisions. So lots of collisions with red deer and roe deer. And so for example, as I already said, actually for each linkage, you could also, you should do an additional study to prove also the functionality. So we did it already a little bit with this overlapping of the national concepts. And yes, this is just a landscape probability model. But for example, here, this is also coming out in several other studies. So it is well known that such a valley with such big human infrastructure and intensive agriculture is a barrier for many species.
everyone short, quick question.
Compliments for work. Question, you are talking about alpine species. What exactly do you mean? Because I guess different species have different requirements. So corridor for one, another one. So I didn't get this target species that you wanted. I mean, connectivity for who?
Here again, this is a structural model. It is a landscape model, and we're focusing on human barriers. So here, the main assumption is that the absence of human barriers is good for connectivity. So we are not focusing on species here actually. And I got also these questions one time, because here insects can fly over. I don't know. So this is an intensive agricultural area. This is treated at least 2 times per year with insecticides, at least 2 times per year, and 30 times with pesticides in general. It is longer than 2 kilometers. So
It's meant to be a hard question.
No, but
to be like, I think it would be smart to sharpen a bit. It would be very working for some species.
yes,
Maybe to sharpen up.
yeah, it is for sure a model for species on land, and not fish species and not bird species.
Thank you very much. So, I
think we are well on time. So now the presentation is mine. So we will see how can I battle with the time. My presentation is about a concept of indicator of landscape fragmentation dynamics, which means how we measure the landscape fragmentation in large-scale areas like states, regions maybe. And of course, very short introduction, you all know it, that the landscape fragmentation is one of the most serious negative anthropogenic impacts, biodiversity, landscape, and so on. It is mentioned in many strategical documents and studies, and its quantification and is very important to know how our efforts in planning and investment measures and evaluate the impact of strategy documents on environment. So we need to calculate it well. The common existing approach, you know very well also, it's effective mesh size, which was created some 25 years ago by Jaik, and it converts an irregular structure of different areas based as barriers into a regular structure, and it has a very big advantage that we can calculate it in some time series, and there is also a CBC version for regional or even municipal level. So that's a probability model expressing the probability that two individuals randomly placed in that calculated area are located within the same polygon. But there are some methodological deficiencies which we try to overcome at least partly. And one of these is overlapping meshes over the border of a study area. Because if you look at the image, normally who calculates, okay, you have in GIS some roads, these are the barriers, you can click it by the state border, and what happens? This mesh is smaller, this one is smaller, but the nature does not know borders. So this here, the mesh continues to the other country, and now you have almost 3 times larger mesh. This one is the same twice, this one also, and that was the first methodological thing we needed. If you calculate effective mesh size just only from the red meshes, you got 64 square kilometers, while if you go over the borders, you get 131, which is twice more. So the first idea was, if we want to calculate new methodology, we have to go over the borders and start to collect data also from the other countries. I know it is quite demanding, especially for some countries where you don't have enough data or you don't know the sources from the other countries. Most of us knows of your country, maybe some others, but sometimes it is quite demanding. So that was the first thing we have to go over. And another one, maybe the worst, is that all barriers in this model, effective size, are assessed as an equal. Is given 1,000 cars per day on the road means it's barrier. unpassable, but in reality, this road, which has 1,000 cars per day, is really unpermeable. I think in the night, there is 1-2 cars per hour, maybe. I think there is still enough time for the animals to cross the road. So it is not a real full barrier. So our vision is incorporate this fact also to the calculation. And the third, it doesn't take into account or any defragmentation measures. So if you have a motorway, a green bridge on it, still effective mesh size, calculate with this section as a completely unpermeable block. So what we our objective given by ministry, because it was a project from the ministry asked by Ministry of Transport, of course, that we want new indicator which describes changes in landscape fragmentation in a realistic and relatively simple algorithm, takes into account the implementation of migration objects, overpasses and also underpasses if possible, build as much as possible on already existing procedures, indicators, calculations, according speaking of migration object and the evaluation, speaking of technical conditions of Ministry of Transport, which is a legally binding document in our country. We would like also that this indicator allows a retrospective evaluation, approximate into the past and forecasting for future according to the plans and the constructions which are prepared. It should provide outputs that are interpretable by map and also by numerical values to compare the development in time, and is usable in concept documents, spatial planning. Of course, since these 25 years since effective mesh size, the GIS made a big progress. So it's a very powerful tool today. So a lot of calculations which should be done in very easy way than before. So here is the concept. What that data we need. So delimitation of calculation area and including overlaps beyond the administrative boundary, which we need sometimes 20 to 30 kilometers in general. We need, of course, spatial distribution of barriers like roads, railways. That was already included in the previous indicator. We need traffic intensity on roads. Land cover data this time also are important for us. And of course, information on migration objects and data positions and so on. The new algorithm has 8 basic steps. I can show you it also. It's nice scheme. The first one, it's actually the effective mesh size. Definition of our polygons, and if you just calculate the dimension size, it is effective mesh size. But we extended it by next steps. First is calculation of effective area of polygon, which means that we look mainly to the built-up areas and deduct them from the general size of polygons. And then we have to work with the permeability of each barrier. We have 2 options. These are the first 2 steps. Oh, sorry. Here some more info that what we changed to effective mesh size. And we in that second step, we deduct all these build-up areas and so on. And this is the base for calculation. Another thing is are these migratory objects. So we have a set of three algorithms. It's based on the migration potential theory. So we have some technological potential given by size of each object, which is available from the data of motorway directorate. Then you can convert it with some nomograms to the value between 0 and 1. 1 is best, 0 is the worst. So and it is evaluation of each migration object roads. You have ecological migratory potential. Also, it is a number from 0 to 1, and it may indicate the suitability of surrounding object. We calculate from 200 meters around the object and say you it is in the forest, it is in the field, it is near the urban place, and of course also if you are near to 0, then if the value of for the object is not good, and the overall potential says it's and overall potential expects that if only is 1 only if the both of the potentials are very high. This means that if you have a good object in the terms of technical size, but the ecological surrounding is bad, you get it still the 0 or something like below near the 0. So still we have an evaluation of each object between 0 and 1. Then we evaluate. So after we evaluate the migratory objects, we can assess the permeability of each barrier in the fragmentation. So for the motorways, 4-lane roads, fenced roads, and in the future, because we have no one, none of them yet, high-speed railways, we calculate the value still again between 0 and 1 as a probability by migration objects, and it is calculated for every 50 meters of the road. And every section got the final value as an average of these partial numbers. If the section is in build-up area, it's automatically 0. And for the traffic intensity, we got one small function based also on the probability how much free time for crossing the road for animals is according to the intensity, and it is something like that for 1,000 vehicles you got 0.7, 0.8, while 10,000 vehicles, I think 10,000 is 0.1, 0.05, something. And the railways are only on, based on the category because there are no train intensities available. So now example of the maps. This is the evaluation of barriers in the study area we use, which is on the border between the Czech Republic and Slovakia. These are the motorways, mainly without any suitable objects, with a few. This is old motorway, no objects at all. While the local roads with 1,000, 2,000 vehicles per day are evaluated quite well. And the final value is given that you always add part of the size of the neighborhood polygon to the final value. All neighborhood polygons are added the part of their size, effective size, to the value. So, what is the important to know that some more examples of the values, and this is the ratio between our new indicator and the effective size. What is important that our new indicator is a fictional value, but better explains where the area is or is not fragmented, in my opinion. And this is the comparison between original effective size and our indicator. And as a spring, the very last slide, we can explain how permeable is motorway, for example. This is an example of the motorway one on the between Czech Republic and Slovakia. And you can see here, we can have such a linear graph and showing that in these areas, there are some smaller bridges. So you have some permeability. Here is the permeability. It is cut here because of build-up. And here is a big viaduct, and here is aqueduct. So it is much better in the Slovakian side. So final words from our side, the pros of the new indicator is that it's more complex model than previous indicators and include these technical and ecological parameters, and and it reacts sensitively to the changes in these parameters. The problem is that the workflow is more complex than math and needs the precise preparation of GIS data. Thank you for attention, and we have 4 minutes for questions.
Hello, in your input data, you only look at roads and railways. What about waterways? And I'm thinking about really strongly human influenced waterways like canals with steep slopes. Because, for instance, in Belgium, we have them a lot. And as you say, during the night, an animal will still be able to cross the road if there isn't a lot of traffic. But the waterway plays down also by so
Okay, thank you. It's a good question. I return to my workflow to this part when we decided whether to use the migration objects or intensity on the roads. It's here we can add another palette point with waterways, but we didn't because there are almost no waterways in Czech Republic. we have one artificial channel for road, which is about 10 kilometers. That's all. And all navigable rivers are, say, semi-natural or canalized, but not a really artificial waterway. But this is quite open methodology, and we are still in the concept now. And here you can add your own palette point like waterways, but you need to decide its permeability. So if you can base it on the technical measures or just the expert visit or something like this, and give this number between 0 and 1 to it, still it works on that 0 is worst, 1 is best. And you can add anything you want to the calculation.
I will just comment on the methodology. You used input measurement of traffic volumes in this case. I have a way to, which I've tested now in the previous project we discussed, that I have a method that you can omit that and calculate a proxy for it instead based on the centralities of the road networks. It worked very well to predict vehicle collisions and so on.
Yeah, definitely. We have a very good traffic census every 5 years, which covers all roads or motorways, first class road, second class road. Only the local roads are not included. Some of them are, but a few. So it is normally enough to run such model. I think that even the best situation is to have a real transportation planning model, which calculates all intensities for you in general, my opinion. But it's the view of someone who works with the transport more than ecology. Okay, so thank you very much. And now I am going to invite Alessia.
Thank you. Okay, thank you. I just need to know if. Okay. Good morning, everyone. I'm Alessia Pilati, and I'm present to you the EUBIOCOR project, which aims at identifying European biological corridors to enhance the trans-European nature network from a macro-regional scale to a local one. So we talked about this also in the first presentations this morning, but as Homo sapiens are heavily fragmenting natural habitats through soil conversion for human expansion, agriculture and expansion, which includes transport infrastructure. But animals and plants like us need these natural habitats for the necessary resources for survival, shelter and food, and have enough space to find a partner. And what is the current situation at European level? There is a decline of the conservation status of protected species and habitats. And for these reasons, we also mentioned all of the strategies that were promoted and proposed earlier. And the EU proposed also the biodiversity strategy for 2030, which aims at protecting at least 30% of land and seas, of which 10% should be strictly protected. That's the reason why at European level also it's promoted the establishment of a trans-European nature network through the creation of ecological corridors. So from these premises, we started the project with the Fondazione Cappellino as project funders, the Wageningen Environmental Research with the role of scientific coordination, and as Europe Research as project and GIS processing manager. The aims of the project, especially for us as GIS manager, were to find the most important areas for the tenant, the resistances to this network, and therefore the potential ecological corridors. From this macro-regional scale, we passed then to a more local area, to a more local scale, trying to find the possible areas, specific areas of restoration through participative approach, and trying to do that using a replicable modus operandi. So the approach is very similar to the one described from my colleague, Peter Lanner. We use the Continuum Suitability Index, which is analysis to understand what is the landscape permeability to biodiversity. It is a structural approach, and we use these 5 indicators: land use, environmental protection, population pressure, fragmentation, and topography. We overlap them, giving a determined weight, and using this rule, and we use this rule. So having an overview of what is the landscape permeability at European level, we then we identified what we think are the most important areas of conservation and the barriers, and then the potential ecological macro corridors. So we started calculating the CSI, and here you can see what should be the most permeable areas to biodiversity in green, and while in red you have the one less permeable. The range is from starts from 1 to 10, and after this we divided this range into 3 categories, are the same described colleague. The SACA 1, which are the most permeable and have the values from 8 to 10. Then what are the SACA 2, this ecological intervention area, the yellow area, from 5 to 7. And the SACA 3, the ones called connectivity restoration areas, which are considered the main barriers. This is the proportion of these 3 kind of areas. And after this kind of analysis, we calculated a resistance surface, which is a matrix with the cost values for each cell. And the range here changes, but we can go in detail later if you want. How we use that to calculate the corridor. So how we did that, we took these green areas, the SACA 1, the ones that are the most permeable to biodiversity, and we overlapped them with the resistance surface. Then we asked the model to find the least cost path, so the path with the lowest resistance between these areas. This is the result. As you can see, it is a quite complex network, and it has a lot of corridors. They are 1,600 corridors, and they have here it shows like the different resistances. So you can see there are I can use this. Yeah, okay. So there are more narrow corridors that corresponds mainly to narrow strip of most permeable areas going through disturbed urbanized areas, while in other areas, more natural areas, the possibilities for these corridors are more. Okay, so starting from this result, a lot of different analyses can be conducted, and we thought that it was important to study the intersection with the motorways. So here in blue, you can see where the previous potential macro corridors, and with the red triangle, you can see the intersection between them and the motorways. While the yellow square is representing the intersection with the built-up areas, and in this case, the squares correspond mainly to the corridors passing through highly urbanized areas, big cities. So we thought that these barriers are quite a lot. There are 1,400, and we decided to do a kind of selection, maybe kind of prioritization of them. So we started selecting the potential corridors first, using a similar approach of the one that Böttcher and Lana used. So we created a sort of constellations between the SACA 1 finding the nearest one, and then we ask the model to connect using only one corridor those constellations. So in this way, we could have like a cleaner view of what are the main barriers for this potential ecological network. Okay, so we saw that in some cases there were already, this is in Switzerland, there are already some green bridges built exactly where the model built the potential macro corridors and its intersection with the motorways. This is a possibility of implementation of the map. So we can go and see where these barriers are exactly and see what's the situation there. Or what we did in the project was to select one part of the network and go more in deep into what's there, who's there, what can be done there. So we carried some further local analysis in Bavaria, close to there is a small river, Große Valley, and we selected some representative species of the area and conducted some functional analysis there. In this way, we could understand better how these habitats are connected and where are the specific areas that could be used for the interventions and implementation of on-the-ground measures. How we did that? We used another GIS model, which is called the LARCH, and was developed by the Wageningen Environmental Research and through the participation processes. So we worked with the municipality and landscape associations. So some final consideration. The one that I present you was is a map, a first step, and to try to give a vision at European level, and but local analysis and functional approach is very effective on the ground, and these two approaches could be effective to try to implement something. We are talking about time, also yesterday, and for us, it was important to try to find something effective. So interventions should be based on a transboundary, interdisciplinary, and horizontal approach. If you want to know more about the project, since I had to simplify, here are some information on this website, or you can ask me or email me and my colleagues. We can talk at the after. Thank you.
I thank you for the perfect timing of your presentation. And do we have some questions?
Thank you. Very interesting. But on your map, there is a large, wide region in the Netherlands, Belgium, and the north of France. What we have to do there? Just nothing?
I don't know if I feel like responding to something like this. This is for sure very impacted area, and we can see probably that's also simplification, and basically, given our indicators here, that was the result. I don't know. I cannot respond. I think to this question, what can be done there? I think we have to go at local level and see and talk with people. And also, I want to precise that we had to simplify also for calculation reasons and take large areas of permeable areas. So some of these green regions had to be cut off, and this is for sure a simplification. So going at local level, I would say it's the best thing to do. And maybe, and maybe then we could add more corridors or like more protected areas, or natural areas in that area.
Thank you.
I think I didn't respond to your question, but
there
it's
are
a
still
very
nature in
difficult
that
question.
region, in the white,
Yes.
but it's much more complicated. And understand this, what you studied and how you studied. But I think we need something like ecological corridors there as well. This is no answer for us.
Yeah.
That's everything I want.
Yes, but that could be let's say a first step, and then for sure it can be improved. So
Okay, thank you.
thank you.
I see a lot of hands rise. So who wants? Okay, so Marita didn't have a question today yet. So
want to know you as the countries have concepts. I will show it later. So this is not really so pure. It is slide.
we have maybe one more question time for one.
Hi, my name's Liam from the Renewables Grid Initiative. I'm sorry I arrived late, so I missed, maybe you mentioned it, but I'd be really interested to know in kind of macro maps like this, to what extent are power lines also considered as potential realization areas of these ecological corridors?
Sorry, if there are other.
Do you consider power lines and electricity grids as potential areas to connect?
No, we didn't.
Let's talk.
Slides saw a differentiation between yellow, red, white. Red Spanish area. Maybe sections of section areas.
I personally saw that a lot of motorways in that areas, someone maybe can have underground passes or like tunnels or supra elevated over roads, and that could be a reason why there are not. And yes, that's, I think, one of the main reasons. There could be less. But for sure, the study and the analysis need more investigation. Thank you for the suggestion.
Thank you very much. And now it's time for Jan's Remm. So,
Hello. Jan Remm from Estonia, and I'm going to talk about my hometown, Tallinn. Green city. As we know well, this greenness and biodiversity increase the living quality for people, and most of people prefer to have some nature in their everyday life. According to the Statistics Estonia, typical Estonian wants to live in the middle of an old forest by the seashore, but at the same time, not far from the city center, next to the grocery, good roads, and so on. And thus, we have two options to move people and homes to the nature and build wide roads, but this can disturb the nature and ecological balance, or to keep and bring the nature to the city. And this demands that the people must adapt with the nature. And also we must keep in mind that sometimes wildlife can cause damages or threats to human life and economy. Well, Tallinn is a capital of Estonia. It's not a big city in European context, around 20 by 10 kilometers in size, and less than 500,000 of people. And what is important in the location is that this is a coastal city next to the, or on the side of the Gulf of Finland. We are mapping the habitats and wildlife or habitat corridors in the city, potential conflict sites for large and medium-sized mammals, and if possible, we propose solutions to improve the integrity of the ecological network city. We cover the species from squirrel and hedgehog to the moose and last carnivores. And this is actually ongoing study. We haven't finished yet, but I think we have still something. Well, in Tallinn we have several green areas, woodlands, grasslands, have a couple of wetlands. We have also two larger lakes, a river, smaller streams, and we have the cliff and its slope habitats that extends through the city. We have several protected areas, including 3 Natura 2000 areas, and I will add that there is no complete or comprehensive green network planned so far. Well, samples. Pirita River and its valley habitats are protected as cliff forest. Calcareous algar grasslands, still some patches remain in the Lasnamäe district. quite recently digged the amphibian breeding pond that is not far from the city center. The Harpu Lake, very important for bats as a feeding area. And the vascular wetland forest trails are very popular as a recreational destination for people. And here you can see what happens if beaver move in. This is the hiking trail, and now trail is half a meter below the water level. So not always price pleasurable. Well, we have counted 35 species of terrestrial mammals. This doesn't include bats and sea mammals. Probably the most noticeable are the large mammals, including large carnivores. Of course, don't have permanent populations in the city, except the jackal lives permanently in the city. But when these large ungulates or moose, wild boar, and Rooji also have permanent populations in the city borders. Well, last spring and winter, we snow tracked and mapped this wildlife activity in the city, and we gathered several existing data sources. And as you see, wild animals are quite common in the city. Yellow dots are the ungulates that are very often present in the border areas or others or the city center. And sometimes even large carnivores have reached or was in the very center of the city. Of course, they are not very welcome there in the city center, but still this cases large carnivores in the city center shows that this ecological network is not important only for this sustainability of populations viability, but also as safe escape path for animals to go out from it. Well, and if it's not a surprise that the city wild or natural habitats in city are strongly fragmented, probably the strongest factors for fragmentation is traffic, but also fencing and globes, also these built-up areas, new houses and businesses. But in Tallinn also these water bodies, sea, lakes, river, that's its limitations, and also the cliff. Fragmentation road through the largest apartment district. This is a 6 to 8 line road, very dense traffic. Even if there is some green corridors between these buildings, then this road is depressed to the bedrock, so it definitely blocks these passages. This is a fence around 11-kilometer fence around Ülemiste Lake. Lake Tallinn gets the tap water from the lake. So the fence protects the lake from the people, but it also slices to the forest habitats and blocks the wildlife movement. We have 2 large limestone quarries right on the border of the city that also either blocks or disturbs the animal movement. And there are some people who have a chance to live in the forest by the sea, not far from the city center, but of course this disturbs this habitat and wildlife there. And here you see sample where was formerly large former peat area. Actually, this was after the peat mining, it was more like a wasteland, but actually there was quite diverse biota, and now it's picked up by businesses, and its habitats are lost, and also this wildlife exit from the city. Well, results, we mapped that these green core areas, dark gray ones, the city, and these focal sites of connectivity, the total 172 focal sites, assessed the quality for its habitat connectivity, and as you see, say that more than half sites there needed some additional measures to improve this habitat connectivity. So, the dominant factor was the barrier obstacles on streets and traffic. Also, light traffic roads are very common. And the next one, dense buildings and man-made slopes, railways, and as said, also natural factors, slopes, pets, bodies. And in more than 3/4 of cases, there are at least 2 factors simultaneously. Next, we looked through the plannings, general and detailed plannings in the city, and assessed the perspective of the focal sites. This is like maybe 10-year perspective from now. And as you see, the focal sites where currently is strong connections, the level decreased by half. The sites where connections is demanded, necessary, is but these actually absent, this will increase more than twice. And if we look at the situation for specifically for large mammals, then the loss of habitat connectivity will decrease further. Some examples. For example, this is Tähetõrni Street on the western portion of the city, which the street was renovated a couple of years ago, and during this also small wildlife tunnels was added. We have monitored the tunnels and active system, but this is like a success story, but this is actually very simple case because the street is not very dense traffic, and also is situated on the city border, basically out from the city. Well, this is actually the only wildlife passage or exit from all of the eastern part of the Tallinn city, like 3x3 meter opening, and also this landscape situation around this passage is not favorable for wildlife corridor and other obstacles as well. Yeah, very good situation. And this is Paljassaare Peninsula, Natura 2000 area that is basically isolated from rest of the world. And we don't have ideas how to make it better. Yes, some animals maybe can go through the sea, reach out, but these coastal moving paths are blocked because on the both sides of the peninsula there are large harbors. Through the city, it's also possible to meet them. Impossible to go. Okay, conclusions. We have reached so far to the results that small overpasses like maybe canopy creatures or squirrels, quite easy to make in most cases. Even a small green bridge is feasible in some cases. But underpasses like tunnels, even small tunnels, are very complicated in the city street because there are very often other communications like water tubes and electrical wiring below the streets, and this is not possible to go under the streets. The wildlife topics should be included in very early stages of plannings because we have experienced that other parts of the plannings are often quite flexible to change before these are fixed. But if they are fixed, then it's impossible to add the wildlife passages there. And related to this, it's important to talk in all stages of the plannings to the other stakeholders that are visited. Actually, task. That's where it's what we have seen, and we can conclude that Tallinn is at least 10 rather 20 years late with this green network. That's very bad or very excellent. Thank you. Okay, I thank you for your attention. I have some points for discussion.
Thank you very much, and we still have time for some questions. One, stand.
Compliments, it's very important to look at the urban area. Do I understand correctly that you're looking exactly at the boundary of the city and inside that's the area?
Almost yes, but if we map this focal size or connectivity size, then we went over the city border, what is behind the border.
It's very great because of the thought was like what the priority corridor areas. One is process. Functional area are really outside and so maybe looking for sites. Size, just not for something. It's lost. Basically, size.
Yes. Of course, we focused on the larger green areas. And as I said, the ongoing study will separate different species because what I demonstrated, there was this large green areas that are important for ungulates, or hares or so, but I didn't show this places of squirrels and hedgehogs that basically places of city and find habitat gardens.
You have many just big spaces in the city and so much traffic in the city is a big problem for you.
Sure. For example, you can see this yellow dots, the large ungulates, and from the other data sources that also included this wildlife collision data, if you see these dots along this large road, then it's mostly the collision sites. Yeah. Happen.
And it is addressed also to agriculture, to forestry. A main part is renewable energy. It is very, very big inside this law. It is urbanization, but traffic. And then I looked to the update on the Union guidelines for development of the trans-European transport network and what is done on this high level. And you can see carbon dioxide is a problem, is a task, NOx, the reduction, and the avoidance of things. But not. If I think about roads, I think about connectivity, I think about fragmentation. So then on that level, we can integrate it. We have the data about the Natura 2000 areas. We have that. And we all our fragmentation. So we have, what we have done is we have visualized the functionality of both systems. Here you see the transport network from the green part, that is a 10G, and we have there the main core areas, Natura 2000 sites, national sites, connected corridors, species migration corridors, landscape corridors, stepping stones, rivers, and the goal for that behind is to exchange of species. And we have also on the other side the transport network, the 10T, and the main core areas are and connected corridors, migration, brackets, are roads, railways, waterways. And the goal is also to exchange. So, concepts and bring it together. What we have done, we don't model anything, went to each country and asked, what kind of concept do you have? And then brought together all these concepts in one map. The process of integration was the selection of the relevant network and elements. We had to look that it will work on European level. There's much more in it, but we can't put it in such a map. We generalized this. That means we eliminated our ecosystem-specific differentiations and unified in differentiation in cars and corridors. And what this is a picture. It is not the truth, but it is a picture to make people from outside thinking about corridors, about fragmentation. If you have a picture, it says much more than 1,000 words. And what we did here is the overview. We had 17 countries. We integrated. There are some countries which are white. Hope in the future we will get the data. And we had also some transnational corridors, the Carpathian corridor and the Alpen Carpathian corridor. And hopefully in the future we get the Alpines. We will see. And then we made a first proposal to estimate barrier effect of the 10T. I will not talk about that. I will only show you that we had estimated some criteria for that. And in the end, we had the first preliminary rules to determine the conflict areas. And this was the way. The first was to look for the whole corridor concepts of the countries. Then we got the existing and planned gray infrastructure in Europe. We had to do something because it's not okay. We had there were many mistakes in the GIS, so we had to correct that. And then we overlaid that and got the first European defragmentation map. So that could be where the red areas are possible restoration sections. But this is not the end. If you use this map, and this is very important for me for the use of the map, we will do it in the GIS. There you can go really deep to the local level. But it is not the truth. I will show you. You have on European scale a very large overview. It's an overview of the degree of fragmentation caused by TNT. And additional information are supra-regional ecological corridors. For example, you have the alpine capacity. And how to use it in the Baierl project, I have listed the explanations we have also in the Baierl project where you can look to go deeper. Then if you go and on national scale, you will see eco corridors from the different concepts of the countries. This is here for Germany. I know this best. It's now updated for the German corridors and also for the defragmentation areas. And these eco corridors, not only in Germany, but in mostly countries, are based on a system of protected areas and habitats configuration and land use or migration of migratory species, large herbivore species. And what we are in need are related indicator taxa or indicator species for the barrier assessment and for the fragmentation plans. But in some cases, countries have that. Then if you go much more deeper on the regional level, you have maps of valuable habitats and mapping of habitat types, regional migration corridors, for example, for lynx and roadkill and railkill hotspots and special corridors. For example, Spain, which are very important for connectivity. And then when you go much more deeper in the planning process, there are other information to take to look where you can defragment. And there we have a parity reconnection plan. This is something which Ladislav told us in the morning, that we have to have a plan which is nearly has the same value as the plan of the transport plans. Anything. Locally. But each other, then we will succeed. And then you go to the local scale, and there you have detailed project specific field surveys, locations of small migratory. That's why we need to know where the insects in that region can pass. Where you need stepping stones, you need minimum requirements for the development of project specific type, location, efficiency, and sustainability of avoidance and mitigation measures, and respective monitoring requirements. And when you are on the lowest level of the site, you are in need to look for the surrounding area and for the hinterland, which is very important for the functioning of such things. So for the future development, what should be done with this map? We need negotiations with the European states to complete the map with missing data, but also where the priorities of the planning is for the determination of the most important EU corridors, but also for the defragmentation area. The nations know much more better what we have to do than we can know if we use the GIS. And it can be an important database for this truly current trans-European network and for the restoration law also, and also for a European defragmentation program. Because with this and overlay that, you can estimate where you will get problems with fragmentation, with cutting of connectivity. And this is possible to estimate how many money will use for a 10T corridor. And this is the thing that And on the lowest level, there is no fighting for such a measure. Because if start very step in the highest level, then yeah, would I say it is logical. Then, thank you. So just one thing, if you want to look up to the other information, the publication is an address. So
As just a small remark, same as a remark Jan made earlier, again, Belgium seems to be a white spot on the
yeah,
map.
if you can, please give me the data. I'm
Yes, so
updating.
I'm welcome to, but I don't know who has been contacted for that. Maybe we have to talk because I'm from the Flemish government and
Yes.
I nothing about this. So
That depends on the people we know, and we know at the EU level, we were 40 institutions which work on that, and we tried to get information.
So I think it's just one example, of course, for Belgium, but if you say it yourself, it's very important to get all the data.
Yeah.
You can just
You're welcome.
conclude that indeed there are important data.
Yeah. Thank you.
For Italy, with talk with Serena Dambrati, for example, of just or the
We had contact, but from Italy, but only local. And this is
I know.
the point. This is not for a European level. This is to people. So if you do that, just give it to us, but we need a national.
Italy has no national concept. It was one study from 2002, which was an analysis. But there is no national concept from an official side for spatial planning or that.
Yes, but if you have an informal concept and we get the permission to put it in the web GIS, we will do that. But we need the permission and we need the concept. And I knew 2002, I had a concept in my fingers, but I didn't found it in the internet.
So thank you very much for your attention. Nice presentations. And enjoy the rest of the conference.